Alright, welcome to this lesson on the P3 optimization framework. So before we get into the abstract world of theory and blah blah blah, let's start with one simple question that I want to make you. So why do we need game performance nowadays? The simple reason is that players demand it. You just need to look on the internet, search anywhere, and you will see that the trend is to increase the frame rate and the hertz that our hardware and software has to support. You will very often see monitors popping up with 240 Hz, and this is only increasing. You will also see Android phones gladly supporting 120 Hz, and also VR headsets like Quest 2 supporting 120 Hz. So what do players expect from you? That your game or experience also renders at these high frame rates. So the problem with this is that 60 FPS can be hard, okay? I take that. But to achieve 120 FPS is hell. You only have 8 milliseconds as budget to reach 120 FPS. And if we are talking about 240 FPS, that is almost impossible. That is lots of sweat, blood, and tears. Very often a combination of them. So if you think that 8 milliseconds is a lot of time, think about it. Just the baseline rendering process. Let's assume that you are just drawing a cube in URP on a mobile device. That can take very well 3 milliseconds of your CPU time. That leaves you with just 5 milliseconds, and guess what? Unity takes even more time to do other types of processing like physics, okay? So this is really hard, okay? So what can we do about this? Well, you need a structured optimization process to succeed in the industry of video games in the upcoming future, okay? You need a framework that whispers to you what your best next step is at any given point in your game optimization journey. Okay, so you need a framework that leads you from 0 to 72 FPS, from 72 to 90 FPS, from 90 to 120, from 120 to whatever else the market is going to demand in the future. Just like an algorithm, you need a process that takes your input, for example, the profiler data that shows the information about your bottlenecks, and gives you an output. It gives you a high performing experience or video game. So let's keep this short, okay? I heard that some people don't like theory, so let's keep it really short. So the P3 optimization framework, seen from a simplified high-level overview, is this. First, you want to define your performance targets, okay? I know how to spell, I know targets is with one S, but I put 3 on purpose to make sure that you understand the importance of this. There is just not one target. There is just not one frame rate. We also care about loading times. We also care about memory budget. We also care about these little things that player notice and review your game for. Okay, so there are more than one performance goal that you have to set for your game. After that, what you want to do is to iterate over the P3 optimization loop. This loop, every time that you iterate over this, is going to give you a substantial performance boost that will get you closer to your performance goal. The first part of this loop is the profile phase. Here, this is all about gathering information, gathering intel that is going to let you decide in the future what your options might be. Okay, this includes any type of profiling tool like RenderDoc or VRMetrics, Unity Profiler, Pix, VTune, etc. So now that you have your information documented, by the way, you are going to move into the plan stage. Here you are going to investigate and weight at least 3 different options that you have in order to combat this bottleneck. And you're going to weight these options according to 4 metrics. The third stage of this performance loop is the perform stage. Here is all about executing the performance optimization option right. And I'm talking about the performance optimization strategy that fits you best for this specific iteration. And this is something that you will be able to decide according to the 4 metrics that you used in the plan phase. Finally, after you have repeated several iterations of the P3 optimization loop, you will just end at your target FPS and at your target performance goals, whatever they might be. Here you want to do a performance retrospective in order to learn from previous mistakes, and here you will just create your do's and don'ts list so that you avoid repeating the same mistakes in the future projects. Now, this is a very simplified view. Each of these steps has sub-steps, but I cannot just reveal to you all of this because this is a paid product and I will be doing a disservice to the customers that I have. So if you want to learn more about the P3 optimization framework, this step-by-step framework that allows you to optimize your game from 0 to your target FPS, go to p3framework.gamedev.guru. But let's cut the chase. I said I would keep it short. So what I'm going to do right now is to show you a quick demonstration on how I apply the P3 optimization framework to one specific problem in Unity. Now, remember, this is just the simplified version of the P3 optimization framework. So you will not see all of the steps that a normal user will have to do, but this is going to be nevertheless quite useful to you. So let's watch this video that I pre-recorded together and let's have some fun. All right, let's see what we have here for optimization in Unity. Does this sound familiar to you? Well, if it doesn't, then I still have spoiled it. You can probably see the title of this project. This is a project called 3D Beginner by Unity. Obviously, this is not a project that was intended for VR, let alone mobile, so we can kind of expect this not to perform so well, okay? But nevertheless, what should we start with? Just deploy it to Quest and let's see how it goes, I would say. Right, let's see how this looks like. Okay, this is nice, 72 FPS. So what's this? Oh crap. Oh, oof. You don't really want to see this, man. Okay. We're about 20 FPS if I just turned around. That's not good. Like, I feel already super dizzy. Don't trust me? Here, have a look. By the way, don't try this at home, okay? It's quite dangerous. So. You see that? 20 FPS. Oof. You don't want to do this at home, okay? Not really. Neither playing at 20 FPS or putting the headset into the webcam. So you saw these numbers just a second ago, right? Like the frame rate and such. These numbers are coming from a tool called OVR Metrics. And sadly, this OVR Metrics tool is not displayed anytime that you stream through the Oculus developer dashboard, like here, okay? You have the streaming option, and sadly, it doesn't show, but it shows on the device. And that's what you saw, okay? You saw the numbers, and you saw that if I turned my back and stopped facing the wall, 20 FPS is not good, okay? You're just going to make everyone sick. So the first step here in the P3 optimization framework was that you have identified that you are not reaching your performance goals. In our case, it is Quest, so it could be about 72 FPS. Once you know that you're not there, what we are going to do is to execute several iterations on the P3 optimization loop. If you remember from the presentation, there are 3 steps in this loop. One is profile, then plan, and then perform, but we are going to focus right now on profile. We know that we are not reaching 72 FPS, which is our performance goal. Actually, we are rather far away from that. We are at about 20 FPS. So I wonder what is going on. And I guess that you wonder that as well. So the first thing we are going to do is to profile and see what is happening. How do we do this? With tools. Now, we have over 10 tools that we could use to see what is going on. But one of my favorite ones is the Unity Profiler, also OVR Metrics, and we might as well need the frame debugger, okay? But for the sake of being fast for this presentation, we are just going to start with the Unity Profiler. So for this, you have to press Ctrl 7 on the editor or Command 7 if you're on Mac. Then you need to attach to the player, to your Quest device. It's normally called auto-connected player. Make sure that you're recording and just put the headset on again and don't look, like just close your eyes if you are at 20 FPS. Otherwise, you're going to feel very sick. Now, it might not work because Oculus Developer Hub might be stealing the ADB server instance. If that is the case, just try again, okay? Just clear the errors and then go to Android player. Let's see if it works now. Maybe we can just select the other Oculus Quest. There it is. So here I am facing the wall, okay? So it's looking good. Now, as soon as I turn around to see the main contents of the scene, just be careful and watch what's going to happen. Okay, now that we have this capture, what we're going to do is to analyze the numbers, all right? So here we can see that indeed there is a period in which we are below 30 FPS. Let's see what is happening here. You can do this several ways. The way I like to do this is by using the timeline itself. So let's see what the CPU is doing here. Okay, so basically we have our main thread and we are spending about 40 milliseconds in rendering. You see that? This is in general way too much for rendering. If you're targeting Quest, you always want to be top 6 milliseconds in rendering when it comes at least to the main thread. So 40 is definitely not good. We could as well inspect the render thread, but we are going to see something quite similar, right? Taking way too much time. Now, you have to ask yourself first, if you see this, where is this bottleneck coming from? We're talking here about the CPU, right? And the CPU is being very busy. You see, we cannot find any label saying something like waiting for GPU or similar. We see the CPU doing actual work. You see these green blocks? This means that the CPU has quite some work to do. Can you guess why is this the case? Well, if we ran this scene in the editor, we can open the stats panel. And here you will see a few numbers that we need to examine, right? We see patches about 2000, triangles about 3 million, and blah, blah, blah. The rest is not that critical. So if you have some experience developing for Quest, you will instantly know that we are way above our budget regarding batches and triangles. Batches is just another word for draw calls, okay? And draw calls is just the way that your CPU has to tell the GPU to render something. So basically we are just rendering too many objects, okay? Basically this is the way that we can simplify the explanation for now. So this number that you see here, 2000, is above our budget. Do you know what our budget is for Quest? About 200. So this is 10 times above this number. This explains why if you go to the profiler, you will see that we are spending way too many milliseconds on the rendering side. And if we go to the wall, you know, this is not the case. We can see that in the rendering section, when we're looking at the wall, we have 20 draw calls. And when we are not, we have about actually 5K, right? So it is even worse on mobile. So the question is, why do we have so many draw calls and what can we do about that? Does it make sense? Remember, we are still in the profile phase. So we are just gathering intel. We are just gathering information that will let us decide later on, okay? So what other type of information do we need? We need to know what is happening with the batches, what is happening with the draw calls. And for this, we have a very juicy tool that is called the frame debugger. Just go to Window, Rendering, not Rendering, Analysis, and Frame Debugger, okay? So here, you can just click Enable. Don't do this on Quest for now, just do this on the editor. It's not going to be one-to-one the same, but this is going to be much faster for you to examine. If you want it to be super accurate, just do it on your target device, but for a first and brief look, you don't have to do this. Just click Enable, and of course, click on the Game tab because Unity decides for some reason there is nice to troll you and switch back to the scene view. So here we are going to see the composition of our draw calls. We see that most of our draw calls are coming from the opaque geometry. And here we see that 300 of them are coming from shadows. So that's very good information to write down. Yes, you need to write down in the profile phase. You can do that somewhere, wherever you want, right? You can do that in the notepad, in a physical one, in your hand. It is up to you. We just need this information to be documented. So 1700 draw calls are being spent here in the opaque rendering section. So if we have a look at these draw calls, you will see the reasons that Unity has in order not to batch it, okay? So we can just be going down and down and down, and it is quite easy to see that most of the times we have way too many draw calls because draw call batching is not working because objects are affected by different forward lights. Okay, so that is very interesting. If that is the case, let's continue our profiling phase. So it is complaining that we have too many forward lights. What are these lights? We can just type T lights. And indeed, we have quite many lights. And it should be no surprise to you. They are all, most of them, real time. Is anyone surprised at why this is at 20 FPS? I am not. Sure, it looks fancy, sure, it looks good, but if it runs at 20 FPS, I'm not going to care about it, okay? I'm just going to probably spend a few hours shaking in bed with fever and super pale. So anyway, what can we do about this? If it says that we have way too many lights, then the obvious thing we can do is to remove some lights, or at least to, bake them in a way that we don't have to do these calculations in real time. That's one option, okay? And by thinking about options, we already advanced to the plan stage, okay? So option number one, remove lights, okay? So one example could be to select these lights and disable this in play mode, okay? I'm just giving you an example. If we do this, you see that the number of patches drop to 400. And this is a really juicy improvement, okay? So that's one option. And most people, we just go for this option and call it a day. They would just do this optimization, go home and say, hey, I'm proud of what I have done, and done with this. If you do this, however, you will see a huge difference in quality, right? Just compare the visual difference here. It is pretty significant. So more options are, don't know, what do you think? Because we're in a presentation, I cannot just wait 10 minutes for people, to come up with questions. So what I'm going to do instead is to give you a few more options. Because remember, in the plan stage, what we want to do is always to think about 3 options. Otherwise, you risk going for the cheapest option that is usually not the best option for the players, okay? So second option would be to go to these lights and say something like baked, okay? Now this is grayed out for some reasons that are not important, but nevertheless, I will show you. So basically we need to go to the lighting tab, then and enable the baked global illumination, okay? So again, we can go to mode and go and say baked, okay? We don't want these lights to be calculated in real time. However, if we do this and then we bake the lighting, let's select for now something like subtractive and then generate lighting. Okay, so this is done. I, by the way, reduced the light map resolution to 4 textures per unit just to iterate faster. So this is not the final result, but don't worry about that. Let's see what happens if I play now. Okay, so 400 batches. That's amazing. That's what we wanted for, at least in the first P3 optimization loop. However, this still looks better than first option, which is just to remove the lights. However, we lose quite some you see effects like, for example, the flickering of the light is gone. Okay, so this is still a better option, so you could totally go for this. Of course, you need to tweak a bit how the scene looks like, right? You need maybe to adjust the static flags and change the light map resolution and all of the settings so that it looks good. And this could be one option. However, we said that we want to at least consider three options. So just think about that. What other options do we have? Now, if you have some experience in game performance optimization, you will instantly recognize something here. If you go through the scene and disable the gizmos, of course, you'll see that this looks quite an indoors scene, doesn't it? And what techniques can we apply when we are in indoors scene and we want to reduce the number of troggles that we have? How cute is this guy? Let me tell you that. Occlusion culling. Occlusion culling is all about not rendering what is being covered by other objects. So if we have a wall here, then no need to render this stuff. Okay, so that will be option 3. Let's just give it a try. Okay, we are just doing super fast testing here. We don't care about the perfect solution, like you can see on the left, right? I mean, this doesn't look perfect to me, although it looks fine enough. Okay, so what we are going to do here is to undo our optimizations. So we are going to our lights because Control Z is not working. Surprise. And actually it worked. My mistake. All right. And then we're going to go for option C, which is to bake occlusion culling. How do we do that? Window, rendering, occlusion culling, and then let's just change the parameters to something that makes more sense. No worry about these parameters. And bake. All right. So now that we baked occlusion culling, everything disappeared. What happened here? No worries. We are in the visualization mode of occlusion culling. So that means that for this camera that we see here, we're going to see what we render and what we don't render. We can disable that visualization by just switching to another tab like bake. So I would say that we are already making some substantial gains. Okay, so basically now if I hit play, we were at 2000 patches and now we are at 79. Very interesting. However, the lights are still not flickering, so something might have gone wrong. Let me check. I know what went wrong. I just forgot to clear the back data. Bad boy, Ruben. Let's play it again. All right, so let's see the stats. 200 patches. All right, this is still quite good. It is quite similar to what we had before by removing the real-time lights and even by converting the real-time lights to baked lighting. And this looks much better. We're talking about this room, of course. If we go to another room, of course, we will need to do some other types of optimization, okay? But step by step. We don't want to optimize everything at once. We want to do small steps that lead to small P3 optimization loops that lead to big gains. So now that we have played with 3 options, we could ask ourselves, is this actually what we need for a performance jump? We might not have come up with the perfect parameters here, but that's fine. What we can do is just to deploy a build and see the difference. So let's just press Control B and be right back. All right, apparently I have found a way to stream this screen, including OVR metrics, without putting the headset on the webcam. I think this is a better alternative. Now, 72 FPS when I'm looking at the wall. I wonder what's going to happen once I turn around. I'm still going to keep my eyes closed just in case, all right? So, ready? Let's go. Whoop. Okay, don't move. All right. That's it. I saw the number. I think I saw a 40. Okay, that was maybe a bit too optimistic. I think I saw a 38. All right, so we went from, let's say, 20 FPS to 38 FPS just by doing this. I wonder what would be the result if we did it correctly. So what you have discovered right now in the plan phase, after some investigation, is that you have three alternatives. One of them is really detrimental to the player. That would be the first one, which is all about removing the lights that are not the main one, the main directional one. That's no good, even though for me as a developer it's quite convenient to do, right? But I care about people and I wouldn't do that. Second option is to make them static. But there, if we do that, then we will miss out on the flickering effects, okay? Option 3, activate occlusion culling and call it a day. So, those baking parameters might not be the perfect ones, but they are a good start. From all of these three options, I would say that my favorite one is by far baking occlusion culling. This could be a good P3 optimization loop. Now it will be the time to go to the perform stage, which is the last step of the P3 optimization loop. Here, we will just need to come up with the right baking parameters for the occlusion culling. Okay, this will be the time to do it right. Okay, then once you're done, then you submit to Perforce, Git, Tortoise, SVN, whatever it is, and then there you can call it a day. That will give you a jump of, about 20 FPS. If you want to calculate that in milliseconds, then just do the math. Of course, in milliseconds, it's a better metric, right? And since we would still not be reaching 72 FPS, then you would need to execute more P3 optimization loops, okay? Of course, there might be more options than the three options that we have seen. Feel free to explore them in different iterations. But honestly, if you manage to go from 20 to 40 FPS in just one iteration, I myself will be super happy about it. And now you just need to iterate over this P3 optimization loop until you reach your performance goal. What's your performance goal is a question, okay? It could be 72 FPS if you're targeting Quest, but it could also be 120 FPS if you're targeting Quest. Because as you know, Oculus just rolled out the 120 FPS upgrade. So now performance optimization, especially in the area of rendering, becomes more important than ever. Can you imagine how well your application or game will just sell if you manage to promote the message that your application supports 120 FPS and hertz? That would be a nice, unique selling proposition, I would say. And reaching 120 FPS is complicated. But if you have a structure, if you have a framework like the P3 optimization framework, you can just do that. You just need to follow a series of steps that will lead you from 0 to 120 FPS. And that is the power of having a proven framework. All right, I hope this was useful to you. And now is the time for you to shoot questions. And, I might not know all of them, but I will try my best to answer each of your questions. Let's go. Okay, shoot. If you like this video, then let me tell you, there is something much better than this. Join my game performance task force, because here is where I post all the good stuff. Here I'm talking about 30 to 40 minute videos where I explain all I have to explain in the area of game performance. Let's have a sneak preview. In this membership, you are going to get one video per week each month. That means in each month, you're going to get the following. In the first week, what you're going to get is a lesson on professional performance. Here is all about making you a high-performing developer. The second week is all about making your CPU run faster. So yes, that includes physics, AI, rendering, and everything alike. In the third week, you are going to receive a lesson on GPU optimization. Here is all about making better graphics cost less. And finally, in the fourth week, you're going to get a lesson on memory performance. This is all about reducing the memory usage, the memory bandwidth, the loading times, and things alike related to memory access. Now, the best thing of this is that once a month, you're going to get access to one live lesson. There you will be able to ask your questions live and connect to other high-performing Unity developers. So if you would like to stay up to date in the games industry, then join my game performance task force, because there is a risk-free guarantee. You can just join for the trial, and if you don't like it, you can leave at any time. But I'm sure you will love this. This is the reason I'm promoting this for you. I know that it's going to be super useful for you, no matter at which stage of your game performance journey you are at. So go ahead to taskforce.thegamedev.guru and see you there.